Here is a very cool example of the slicing method. So you see a petri dish with lots of bacteria colonies, and it's a very natural question to ask how many bacteria are in these colonies. And we can use the slicing method to compute this. So let's, for example, use this beautiful round colony sitting right here and try to find out with a little bit of measurements how much bacteria are sitting in there. So here's my colony again I'm looking at. We measure that the colony has a radius of 1 centimeter, and then we can measure the density profile of the bacteria in radial direction. You can clearly see that there are more bacteria in the middle than there are on the sides. So we estimate this to be d of r is 1 minus r square in million cells per centimeter squared. Let's visualize this graphically. So in radial direction we have this function d of r, which is an upside down parabola. 1 minus r square, here is 1. Here is d of r is 1 minus r square. So then up here is equal to 1. Now again we use the slicing method. So we slice the radius. So we radially have a little slice which we call dr right here, indicated in purple. Now looking at the entire bacterial swarm or the entire bacterial colony there, this dr corresponds to a ring which goes around the colony. So to draw this, I need to extend my picture a little bit. So this would be then a visualization of the entire swarm, and then this little radial bit corresponds to this ring here. So this here would be a typical slice. And what is the area? The area of this typical slice, I call this maybe dA. This would be width times length. So then the width would be dr. And the length is just the circumference of a circle, so it is 2 pi r. So then we have a little formula for this area. And now we can go up here and say that the number of bacteria in a slice, and this I call dB, this would be then the density d of r times the area, or this is the density at r times 2 pi r dr from down here. And then we can even sub in the density formula 1 minus r square 2 pi r dr. Okay, so this needed a little bit of mental gymnastics to understand that this is actually a ring in the entire colony. Okay, let's integrate this now. So then we have that the total bacteria count is b integral dB. And so now the radius is integrated from 0 to 1. And then we had 2 pi r 1 minus r square dr. And all of a sudden we have a beautiful polynomial integration to do, which should be rather easy to be done. So then this is integral 0 to 1 2 pi r minus r cubed dr. So integrate this. I keep the 2 pi and I integrate the rest. We get r square half minus r to the 4 quarters between 0 and 1. And then this is 2 pi times 1 quarter, and then this is pi over 2. Aren't you impressed how quickly I can do this? What are the units? Let's go back. The units here for the dr is million cells per centimeter square. And the centimeter square falls out through the integration with the area. So what this means is million cells.